The construction of Roman roads represented one of the most enduring engineering achievements of the ancient world, developing over centuries through careful observation and methodical refinement of construction techniques. The Roman road system extended across the entirety of the Roman Empire, from the British Isles in the northwest to the Euphrates River in the east, and from the Rhine and Danube rivers in the north to the Sahara Desert in the south. The total length of the Roman road network at its peak exceeded 400,000 kilometers, connecting over 300 major cities and countless smaller settlements throughout the provinces. The construction of these roads began in the 4th century before the Common Era and continued for over 600 years, with new roads being added as the empire expanded and existing roads being maintained and repaired by successive generations of engineers and laborers. The primary purpose of the Roman road system was military, allowing legions to move quickly from one part of the empire to another in response to threats or rebellions, but the roads also facilitated trade, communication, and administrative control throughout the vast territories under Roman rule. The planning and surveying of a new Roman road began with the selection of a route that would connect 2 points in the most direct manner possible, as the Romans preferred straight lines whenever the terrain permitted. Surveyors known as agrimensors used specialized instruments to establish the path of the road, including the Groma, which was used to establish right angles and straight lines, and the Chorobates, which was a leveling instrument used to determine gradients and elevations. The Groma consisted of a vertical staff with a horizontal cross at the top, from which 4 plumb lines were suspended at right angles to each other, allowing the surveyor to align the instrument with distant markers and establish a straight line of sight. The Chorobates was a long wooden beam approximately 6 meters in length, supported on legs and equipped with a water channel along its top surface, allowing the surveyor to determine whether the ground was level by observing whether the water remained at the same height along the channel. These instruments were carried by the surveying team along with measuring rods, chains, and marking stakes that were used to mark the established route at regular intervals. The surveyors would walk the proposed route, taking measurements and noting obstacles such as rivers, marshes, hills, and forests that would need to be addressed during construction. Once the route had been surveyed and marked, the construction of the road began with the excavation of a foundation trench that would contain the various layers of material that formed the road surface. The width of the trench varied depending on the importance of the road, with major highways such as the Via Appia being approximately 4 to 5 meters wide, while secondary roads might be only 2 to 3 meters wide. The depth of the trench also varied depending on the local soil conditions, with deeper excavations required in areas with soft or unstable ground. The excavation was performed by laborers using picks, shovels, and baskets to remove the soil and transport it away from the construction site. In some cases, the excavated soil was used to build up embankments on either side of the road or to fill in low areas along the route. The bottom of the trench was compacted, using heavy wooden rammers or stone rollers to create a firm foundation for the layers of material that would be placed above it. The construction of a Roman road involved the placement of multiple distinct layers of material, each serving a specific purpose in the overall structure of the road. The lowest layer was called the Statumen, and consisted of large stones or rubble that were placed directly on the compacted foundation. These stones were typically between 15 and 30 centimeters in diameter and were arranged by hand to create a stable base that would distribute the weight of traffic across the underlying soil. The Statumen layer was approximately 15 to 20 centimeters in thickness and was carefully leveled to provide a uniform surface for the layers above. The second layer was called the Rudus and consisted of smaller stones mixed with lime mortar or clay to create a more solid and cohesive layer. The stones in the Rudus layer were typically between 5 and 10 centimeters in diameter and were compacted using heavy rollers or rammers to achieve a dense and stable surface. The Rudus layer was approximately 20 to 25 centimeters in thickness and provided additional strength and stability to the road structure. The third layer was called the Nucleus and consisted of a mixture of crushed stone, sand, and lime mortar that was spread and compacted to create a smooth and level surface. The Nucleus layer was approximately 15 to 20 centimeters in thickness and served as the bedding layer for the final surface course. The materials for the Nucleus were carefully selected and processed to ensure consistency in size and composition, with the crushed stone being screened to remove any particles that were too large or too small for the intended purpose. The lime mortar was prepared by burning limestone in kilns to produce quicklime, which was then slaked with water to create a paste that could be mixed with the crushed stone and sand. The mixture was spread evenly across the Nucleus layer and compacted using heavy rollers pulled by oxen or other draft animals. The final layer was called the Summum dorsum or summa crusta and consisted of large paving stones that were fitted together to create the driving surface of the road. These stones were typically made of basalt, granite, or other hard volcanic rock that could withstand heavy traffic and resist weathering over time. The paving stones were cut to regular shapes and sizes, typically between 30 and 50 centimeters in length and between 15 and 25 centimeters in width, with a thickness of approximately 15 to 20 centimeters. The stones were laid in a pattern that interlocked the edges and corners, creating a surface that would not shift or separate under the weight of passing vehicles. The gaps between the stones were filled with smaller stones or gravel to prevent water from penetrating the road structure and to provide a smoother surface for wheeled traffic. The surface of the road was designed with a slight crown or camber, with the center of the road being higher than the edges to allow rainwater to drain off to the sides rather than pooling on the surface. The camber was typically between 15 and 30 centimeters from the center to the edge of the road, creating a gentle slope that was barely perceptible to travelers but effective at shedding water. On either side of the road, drainage ditches were excavated to collect the runoff water and carry it away from the road structure. These ditches were typically between 30 and 50 centimeters in depth and between 50 and 75 centimeters in width, with sloping sides to prevent collapse and regular cleaning to maintain their capacity. In areas where the road crossed streams or rivers, bridges were constructed to carry the road over the water without interrupting the flow. Roman bridges were built using stone arches that distributed the weight of the road and traffic to the supporting piers and abutments. The arches were constructed using precisely cut stone blocks that were fitted together without mortar, relying on the compression forces within the arch to maintain stability. The spans of Roman bridges varied depending on the width of the watercourse, with typical spans ranging from 5 to 15 meters for smaller streams and up to 30 meters or more for major rivers. The piers were founded on wooden piles driven into the riverbed or on stone foundations that were built within cofferdams that allowed the construction to proceed in dry conditions. The construction of the road also included the placement of mile markers at regular intervals along the route to indicate distances and provide information to travelers. The Roman mile was approximately 1,480 meters in length, slightly shorter than the modern mile of 1,609 meters. Mile markers were typically stone columns or pillars that were inscribed with the distance from the starting point of the road, the name of the emperor or magistrate who ordered the construction or repair of the road, and sometimes additional information such as the names of nearby towns or landmarks. These markers were placed on the side of the road at each mile interval and served both practical and ceremonial purposes, demonstrating the reach and organization of the Roman administration throughout the empire. In addition to mile markers, the roads featured rest stations known as mutationes and mansiones that provided services to travelers. Mutationes were smaller stations located approximately every 10 to 15 miles where travelers could change horses or obtain fresh mounts for their journey. Mansions were larger establishments located approximately every 25 to 30 miles where travelers could obtain lodging, meals, and other services during longer journeys. These stations were maintained by the imperial administration and staffed by officials who managed the facilities and provided assistance to authorized travelers. The labor force required for the construction of Roman roads was substantial, with large numbers of workers needed for excavation, material preparation, transportation, and placement. The core of the labor force consisted of Roman soldiers who were assigned to engineering duties as part of their military service. Legionaries were trained in construction techniques and were equipped with the tools necessary for road building, including picks, shovels, hammers, chisels, and measuring instruments. A typical Roman legion of approximately 5,000 men could dedicate a portion of its strength to road construction while maintaining other military duties, with engineering cohorts specializing in construction projects. In addition to soldiers, the labor force included slaves who were owned by the state or by private contractors who were hired to perform specific tasks. Slaves were used for the most physically demanding work such as excavation, stone quarrying, and material transportation. Free laborers were also employed for specialized tasks that required particular skills, such as stone cutting, masonry, and surveying. These workers were paid wages that varied depending on their skills and the difficulty of the work, with skilled craftsmen receiving higher compensation than unskilled laborers. The organization of the labor force was hierarchical, with engineers and surveyors at the top, followed by foremen who supervised groups of workers, and finally the laborers who performed the physical work. The materials required for road construction were obtained from local sources whenever possible to minimize the cost and effort of transportation. Stone for the various layers of the road was quarried from nearby deposits, with the type of stone varying depending on the local geology. In volcanic regions such as central Italy, basalt and other volcanic rocks were commonly used due to their hardness and durability. In other regions, limestone, granite, or sandstone might be used depending on availability and suitability for the intended purpose. The quarries were operated using hand tools such as picks, hammers, and chisels, with the stone being cut into blocks of manageable size for transportation and placement. Wooden wedges were sometimes inserted into natural fissures in the rock, and then soaked with water to expand and split the stone along desired lines. The quarried stone was transported to the construction site using carts pulled by oxen or other draft animals, with the roads themselves being used to facilitate the transportation of materials for their own construction. Lime for the mortar was produced by burning limestone in kilns that were constructed near the quarry sites or along the route of the road. The limestone was heated to high temperatures to drive off carbon dioxide and produce quicklime, which was then transported to the construction site and slaked with water before being mixed with other materials. The maintenance of Roman roads was an ongoing responsibility that required regular inspection and repair to keep the roads in usable condition. The wear and tear from constant traffic, combined with the effects of weather and time, inevitably caused damage to the road surface and structure that needed to be addressed. Inspection teams traveled along the roads at regular intervals to assess their condition and identify areas that required attention. These inspections were recorded in official documents that noted the location and nature of any defects, the recommended repairs, and the estimated cost of the work. Minor repairs such as filling potholes or replacing individual paving stones could be performed by local maintenance crews who were stationed along the road at regular intervals. More substantial repairs, such as rebuilding sections of the road foundation or reconstructing bridges, required the assignment of larger work crews and the allocation of additional resources. The funding for road maintenance came from various sources, including imperial revenues, provincial taxes, and sometimes contributions from local communities or wealthy individuals who benefited from the roads. Inscriptions on mile markers and other monuments often recorded the names of emperors or officials who had ordered repairs or improvements to the roads, serving both as historical records and as political propaganda demonstrating the beneficence of Roman rule. The design and construction of Roman roads varied somewhat depending on the region and the specific requirements of the route. In mountainous areas, roads were constructed with switchbacks and tunnels to navigate steep terrain, with retaining walls built to support the road on hillsides. In marshy or low-lying areas, roads were built on raised embankments to keep the surface above the water table, with additional drainage works to manage the flow of water. In urban areas, roads were paved with smoother stones and integrated with the city street system, with sidewalks and drainage systems designed to accommodate pedestrian as well as vehicular traffic. The Via Appia, one of the earliest and most famous Roman roads, was constructed beginning in 312 before the Common Era and extended from Rome to the port of Brindisi on the southeastern coast of Italy. The Via Appia served as the model for subsequent Roman roads, establishing the construction techniques and standards that would be used throughout the empire. The road was constructed with the full layered structure described above, and sections of the original paving stones can still be seen today, demonstrating the durability of Roman construction methods. The Via Flaminia, constructed beginning in 220 before the Common Era, connected Rome to the Adriatic coast and served as an important military and commercial route. The Via Aurelia ran along the western coast of Italy, while the Via Cassia connected Rome to Tuscany and beyond. These Italian roads formed the core of the network that would eventually extend throughout the Mediterranean world and beyond. The expansion of the Roman road network accompanied the expansion of the empire itself, with new roads being constructed as new territories were conquered and incorporated into the Roman system. In Gaul, modern France, roads were constructed connecting the major cities and military installations, with the Via Domitia linking Italy to Spain through southern Gaul. In Britain, roads such as Watling Street and Fosse Way connected the major settlements and military bases, with many of these routes still forming the basis of modern British roads. In the eastern provinces, roads connected the cities of Greece, Asia Minor, Syria, and Egypt, facilitating trade and administration throughout the region. The total investment in road construction over the centuries of Roman rule was enormous, representing a significant portion of the imperial budget and requiring the coordination of vast resources and labor forces. The benefits of this investment were equally substantial, enabling the rapid movement of military forces, the efficient collection of taxes, the facilitation of trade and commerce, and the integration of diverse peoples and regions into a single political and economic system. The Roman road system remained in use long after the fall of the Western Roman Empire, with many routes continuing to serve as important transportation corridors throughout the medieval period and into modern times. The engineering principles and construction techniques developed by the Romans influenced road building for centuries, with elements of Roman design appearing in roads constructed well into the 19th century and beyond. The legacy of Roman road construction extends beyond the physical remains of the roads themselves to encompass the organizational and administrative systems that made such large-scale infrastructure projects possible. The Roman approach to road building combined technical expertise with systematic planning and execution, creating a model for infrastructure development that has been studied and emulated throughout history. The surveying techniques, construction methods, and maintenance practices developed by Roman engineers represented the state-of-the-art in ancient civil engineering, demonstrating a level of sophistication that would not be exceeded until the modern era. The inscriptions and documents that recorded the construction and maintenance of Roman roads provide valuable information about the organization of the Roman state, the allocation of resources, and the priorities of successive emperors and administrations. The archaeological evidence of Roman roads, including surviving sections of pavement, bridges, mile markers, and roadside installations, continues to be studied by historians and archaeologists seeking to understand the ancient world and the achievements of Roman civilization. The romantic image of Roman roads as straight arrows piercing through the landscape has been somewhat modified by modern research, showing that Roman engineers were pragmatic in their route selection, following the contours of the land when necessary, and deviating from straight lines to avoid obstacles or take advantage of favorable terrain. Nevertheless, the overall impression of Roman roads as marvels of engineering and organization remains valid, reflecting the capabilities and ambitions of the civilization that created them. The construction of each Roman road represented a significant undertaking that required years or even decades to complete, with work proceeding in stages as resources became available and priorities shifted. The initial survey and planning might take months or years depending on the length and complexity of the route, with surveyors walking the terrain multiple times to refine the alignment and identify potential problems. The excavation and foundation work might then proceed for several years, with laborers working through multiple construction seasons to complete the earthworks and prepare the roadbed. The placement of the various layers of material might take additional years, with the sourcing, preparation, and transportation of materials requiring careful coordination and management. The final paving and finishing work might take yet more time, with skilled craftsmen carefully laying the surface stones and completing the drainage systems and roadside installations. Throughout this extended process, the work was subject to interruptions due to weather, military emergencies, changes in administration, or shortages of labor or materials. The completion of a major road was often celebrated with ceremonies and inscriptions that recorded the achievement and honored those responsible for its construction. The opening of a new road was a significant event that improved connectivity and economic opportunity for the regions served, and was often marked by the establishment of new settlements or the growth of existing communities along the route. The daily routine of workers on a Roman road construction site followed a regular pattern that was dictated by the availability of daylight and the physical demands of the labor. Work typically began at sunrise, with workers gathering at the construction site and receiving assignments from their supervisors. The morning hours were devoted to the most physically demanding tasks, such as excavation, stone quarrying, and material transportation, taking advantage of the cooler temperatures of early morning. A break was taken at midday for rest and meals, with work resuming in the afternoon for lighter tasks, such as surveying, stone cutting, and finishing work. The workday ended at sunset, with tools being collected and stored, and workers returning to their camps or nearby settlements for the night. The camps themselves were organized according to military principles, with designated areas for sleeping, eating, tool storage, and administrative functions. Food was provided from central kitchens that prepared meals for the workforce, with rations consisting of bread, porridge, vegetables, and occasionally meat or fish depending on availability. Medical care was provided by camp physicians who treated injuries and illnesses that occurred during the course of work, with hospitals established at larger construction sites to handle more serious cases. The discipline and organization of the workforce ensured that progress was maintained consistently over the extended periods required to complete major road projects. The tools and equipment used in Roman road construction were simple by modern standards, but effective in the hands of skilled workers. Picks and shovels were used for excavation, with the picks having pointed ends for breaking up hard soil and rock, and the shovels having broad blades for moving loose material. Hammers and chisels were used for cutting and shaping stone, with various sizes and shapes available for different purposes. Measuring instruments including rods, chains, and ropes were used to establish dimensions and alignments, with the surveying instruments described earlier used for more precise work. Carts and wagons were used for transporting materials, with wheels constructed from wood and sometimes fitted with iron rims for durability. Lifting equipment including cranes and pulleys was used for handling heavy stones, particularly in bridge construction and other situations where large blocks needed to be positioned precisely. All of these tools required regular maintenance and replacement, with blacksmiths and carpenters employed at construction sites to keep the equipment in working order. The investment in tools and equipment represented a significant portion of the cost of road construction, and their proper care and maintenance was essential to maintaining productivity and safety on the work site. The completion of the Roman road network represented one of the greatest infrastructure achievements of the ancient world, creating a system of transportation and communication that bound together an empire spanning 3 continents. The roads facilitated the movement of armies, the collection of taxes, the conduct of trade, and the administration of justice throughout the vast territories under Roman control. The economic benefits of the road system were substantial, reducing transportation costs and enabling the efficient movement of goods from areas of production to areas of consumption. The social and cultural effects were equally significant, enabling the spread of Roman language, law, and customs throughout the provinces and facilitating the integration of diverse peoples into a common civilization. The roads also enabled the spread of Christianity in the later centuries of the empire, with missionaries and travelers using the road network to carry their message to distant communities. The decline of the Roman road system accompanied the decline of the empire itself, with maintenance becoming sporadic and eventually ceasing altogether in many areas as resources were diverted to more pressing needs, and the administrative capacity to coordinate large-scale infrastructure projects deteriorated. Many roads fell into disrepair, with paving stones being removed for use in other construction projects, and the underlying layers being eroded by weather and time. Nevertheless, the routes established by Roman roads continued to be used throughout the medieval period and beyond, with many modern highways following the alignments established by Roman engineers over 2,000 years ago. The physical remains of Roman roads continue to be visible in many parts of Europe, North Africa, and the Middle East, serving as tangible evidence of the engineering capabilities and organizational achievements of Roman civilization. The story of Roman road construction is ultimately a story of human effort and ingenuity applied to the challenge of creating lasting infrastructure using the materials and techniques available in the ancient world. The roads were built by countless workers whose names are lost to history, who labored under difficult conditions to create something that would outlast their own lifetimes and serve generations to come. The engineers who designed and supervised the construction brought technical knowledge and practical experience to bear on problems that required creative solutions and careful execution. The administrators who organized and funded the work demonstrated the capacity of the Roman state to mobilize resources and coordinate activities on a scale that was unprecedented in the ancient world. The result was a network of roads that facilitated the movement of people and goods across vast distances, connecting communities and enabling the exchange of ideas and culture, as well as commerce. The roads stand as a testament to the ambition and capability of Roman civilization, and to the enduring human desire to create connections and overcome the barriers of distance and terrain. The construction process moved forward with steady rhythm, each layer being placed upon the previous one in a logical sequence that had been refined through generations of practice. The surveyors walked the land, the laborers dug the earth, the stonemasons cut the rock, and the engineers oversaw the work, each playing their part in the creation of something greater than any individual contribution. The roads stretched across the landscape like veins through a body, carrying the lifeblood of commerce and communication to every corner of the empire. The sound of hammers on stone, the creak of cartwheels, and the voices of workers created a constant background of activity that marked the passage of time in the construction camps. The completion of each section was celebrated, but the work continued, always extending further, always connecting more places, always serving the needs of an empire that seemed destined to last forever. The roads remained long after the empire fell, silent witnesses to the rise and fall of civilizations, the coming and going of countless travelers, the slow passage of centuries. The stones that were laid with such care continue to rest in the earth, waiting to be discovered by archaeologists and admired by those who walk upon them today. The story is complete, the work is done, the roads are finished, the empire is gone, but the roads remain. The silence of the ancient stones speaks of patience and permanence, of work well done and time well spent. The traveler of today walks where the traveler of 2,000 years ago walked, following the same path, seeing the same landscape, connected across the centuries by the enduring work of Roman hands. The road continues, the journey continues, the story continues, into the quiet of the night and the peace of sleep. The work is finished, the rest is earned. The road is complete, the sleep is deep. The stones are still, the earth is quiet, The night is calm, the sleep is peaceful. The road is done, the story is told, the history is written, the sleep is here, the end is reached, the rest begins, the quiet settles, the sleep comes. The road waits, the stones rest, the night falls, the sleep arrives. The history is complete, the work is finished, the road is silent, the sleep is deep.